Guys, so let's go through this review. We're going to be talking about what makes a sequence arithmetic. So remember, what makes a sequence arithmetic is a common difference. So again, what that means is like a sequence that increases the same amount each time. So if I have a sequence 1, 2, 3, 4, 5, just this normal counting sequence, it's increasing by 1 each time. Between each term. So that's a common difference there. So this would be an arithmetic sequence. Another example of a common difference arithmetic sequence. What I'm talking about is, well, 5, 4, 3, 2, 1. This common difference is going down by 1, so negative 1. So the common difference is the answer for question 1. Now, which sequence is arithmetic is you have to actually find the difference. If the difference between the terms is the same, then we're dealing with an arithmetic sequence. If they're different, well, then it's not an arithmetic sequence, and it's going to be no. So this is going back to, I don't know if you guys remember this, but like we're going to take A3 and minus it from A2. So remember, these are supposed to be tiny numbers, but we don't really have it there. So what A3 is our third term, so 7, take away, and our second term is 4. And what does that equal? That equals, well, 3. Positive 3, keeping that in mind. Okay, so now we're not done yet. We got to check another thing. So we think right now that 3 is our difference. But we don't know if this is actually an arithmetic sequence, so we got to take more terms into consideration. So we're going to look at A4 next, and we're going to take it away from A3. And let's see what we get. So A4 is 10. We're going to take it away from 7. So what do we get? 3. Well, there you go. You notice 3 and 3, it's a common difference, it's the same. So that means that this sequence right here, 1, 4, 7, 10, 13, is arithmetic because it has a common difference of 3. Again, we're going to do the same thing over here. The difference in this one, we're going to take A3, minus it from A2. That's going to give us 3 minus 1, 2, sorry, haha. Okay, cool, that's done. Now we're going to take A4 and minus it from A3. So let's see if what the difference is. Remember, if the difference is the same, oh, I didn't give the answer. It's 1, but you guys probably already know it. Now remember, if the difference is the same, if this difference comes out to 1, then it is arithmetic. But if it comes out to a different number, then it is not an arithmetic sequence. This 1, 2, 3, 5, 8, 13. So 5 minus 3 is 2. Okay, look at that. 1 and 2, it's not the same, so this is not an arithmetic sequence. So let's write that in. Not an arithmetic. I think I just spelled that wrong and it's right up here. I'm just lazy. Sequence. Oops. Sequence. So this is not arithmetic, this one right here. Okay, so there we go. That's how we check. Now, given this arithmetic sequence. Okay, so right here we know that this is arithmetic. We just got to find the difference. Well, we're actually doing that right here, except for since we know this is arithmetic, we only have to find it once. We only have to find one difference, and we know that that is. So how we're going to do that is we're going to take A3 minus it from A2, and that is our difference. So let's do that. So our third term is 15. Our second term is 9. And that equals a whopping 6. So our difference here, D equals 6. So that's how you find your difference. You just take your third term and you minus it from your second. That's going to give you your difference. Okay, question 4. Given this sequence 5, 12, 19, 26, find A1. Okay, so we got to find A1. Remember, use this formula. So this is the formula we always talked about. So, oh, that's not supposed to be A1, is it? Wow, Miss Harper, you messed up a little bit. That's supposed to be A10. Oops. Well, let's fix it here. We're trying to find I'll fix it right now. My bad. My badness. Find A10. Remember. Or actually I'll do this. Put it right, there you go. Find A10. Oh no, I messed up. That's okay. So hint, we gotta create, remember this awesome formula I said we were going to use really lots. Whoops, that's my ugly signature. So let's use it. Always, even though we see it right there, always write your formula down. A1 plus D n minus 1. Okay, so there's our nifty formula. Now, let's start filling in what we don't. We don't know an yet, but we do know that we want to find a10, right? So we're going to plug in a10. That's what we want to find. Remember, n is just a variable that it could be 100, it could be whatever you want. Right now, we want to find a10, so we're going to put a10. Our first term is just the first one here, so 5. Remember, a1 means first term. Let's actually write this right here. A1 equals first term. Okay, now we know that. Okay, plus, oh, what's our difference? Let's do some work over here. So remember, if we take A3 minus it from A4, that's going to give us our difference. So A3 is 19. We take away that from 12, that's going to give us our difference. So 19 take away 12 is 7. So 7 equals our difference. So we can plug that in right here. 7, bracket our n. Well, we're looking at a10, so our n is 10. We're going to take away 1. All right, now our next step is to just plug and play. So we don't know a10 yet, so we're just going to leave it. It's going to equal. Now, with BEDMAS, we got to figure out what we're going to do first. Are we going to add this 5 and 7? We're going to go 7 times this, or are we going to do the brackets? I hope everyone's saying brackets, which is correct. We have to do the brackets first. Can't do anything before we figure out 10 minus 1, which is 9. Now we're going to BEDMAS again. Are we going to add 5 plus 7 or times 7 times 9? According to BEDMAS, multiplication does override addition, so we are going to multiply 7 times 9, which is 63. And finally, we're going to do our last step. A10 equals, what's 5 plus 63? Well, it is 68. Oh, I couldn't solve it there. So A10 in this term is 68. Whoops, well that was weird. All right, we're only going to be doing these ones for today, and then I will do some tomorrow. So, an arithmetic sequence has a common difference of 8. Okay, that's really important information. And A15 is 119. Okay, find an. So they want us to find this formula right here, which is pretty much this one right here. Okay, they want us to find that formula. So let's actually use that formula because that's what we're trying to find. And let's plug in all the information we know. So I hope that we remember what this means right here. 119, that is going to be our an. So this is going to be our an. Where's the little arrow things? That's going to be our an. It's a weird color. Yeah, that's weird. That's going to be our an. Right there. This 119 is our an. Okay? Only if we have A15. Okay, that's why we can't just say, oh, an is 119 and that's it. No, that's an is only 119 if a is 15. So we need to find just the basic an if we ever just want to plug it in into our formula. So let's, now that we have that established, that's a really important thing. Let's use this formula that we want to find. We want to find an equals a1 plus d n minus 1. So let's start plugging in what we know so far and what we can do. So we know 119 is an right here. These two are the same. And that equals, well, that's what we're missing. We don't know a1. So that's what we actually have to find. But we know the difference. It tells us it's 8. And now what do we know for n? So an is 119 when n is actually 15. Okay. So now, again, what can we do first here? Can we multiply this 8 in? Can we do anything with this 119? Not yet. We have to always do the brackets first. So let's do the brackets first. A1 plus 8. And then 15 minus 1 is a whopping 14. So then our next step, we can't do anything on this side yet, it's just alone, but we can multiply 8 times 14 equals A1 plus, now 8 times 14 comes out to a whopping 8 times 14, 112. Oh, we're super close to finding that A1. Now our last step is we got to figure out a way to get this 112 to the other side. And I hope everyone remembers that in order to get something to the other side, you got to do the opposite of what it's doing. Right now, this 112 is adding. So we got to subtract it in order to bring it over to the other side. And what you do to one side, you got to do the other, so we got to subtract it on that side too. So that means what we're left is, well, 119 minus 112 is 7. And that equals, this comes out to 0, and all that's left is A1. Oh my god, we found A1. But this isn't asking for A1. It's asking you to find AN. It's asking you to find the formula of any number. So now we can finally do that because we have the first one. So we know AN equals A1 plus, you guys are probably sick of this formula, D times bracket N minus 1 bracket. So we know now that AN equals 7 plus 8 N minus 1. Now anyone can come in the room, pick N to be 1,000,000, pick N to be 100, and solve using this formula. And we did it. So this is what we're going to do for today. Tomorrow there'll be an update on sum. Okay, I'll see you guys later. Hope you guys are doing really good at studying. Your test is going to look exactly like this, just a couple different things that are going to be different, the numbers. So if you study this well, you'll do perfect.